chapter 4.4, dealing with powers of monomials. To find powers of monomials, we are going to have power of a power. Power of a power. Yes, that's how I explain it. When you have a power, when you have an exponent of a term with an exponent, we are going to multiply those exponents. And if we think about it, 2 to the third to the fourth is 4 2 to the thirds. We have 4 of those. So technically that equals 2 to the 3 plus 3 plus 3 plus 3. And 3 added to itself 4 times is just like multiplying 3 times 4. Yep, which equals 2 to the 12th. All right, so one of the things I talk about power of a power when you have 2 things inside, we are going to distribute. This is the only time you can distribute. And when you distribute it to a negative, you need that parenthesis. Very important. That should be a caution. It doesn't have a caution. But this caution just says, hey, you should differentiate between when we are multiplying exponents and when we are adding exponents. So that's what that caution focuses on. This is more of a caution when you have a negative number inside the quantity. Make sure that it is the quantity of -2, because as we saw in the problem before, in 4.3, that negative inside and outside will make a huge difference. So keep track of that, please. And we'll see it with some of our examples. So we have a to the 2 times 3, which is a to the 6. We have x to the 4 times 3, which is x to the 12th. We have t to the 5 times 3, which is t to the 15th. We have c to the 3 times 3, which is c to the 9th. We have t to the 2 times 3, which is t to the 6th. We have x to the 5th times 2, which is x to the 10th. We have y to the 10 times 3, which is y to the 30th. We have a to the 7 times 8, which is a to the 56. Now, we have multiple terms inside here, so we are going to distribute. We're going to distribute that square to the 5 and the square to the a. Now, let's think about this. There's 2 ways we can do this. We can see that that is 5 to the first, a to the first. So we could do 1 times 2. I'm okay with that if you want to write that. We're still distributing that to each of them. So we get 5 to the second, a to the second, which is 25 a to the second. We have a negative. Be aware of the negative. So when we write this, that's -6 to the 1 times 2. That's x to the 1 times 2. -6, quantity -6 squared, x squared. That's going to be -6 times -6, which is positive 36 x squared. Going back to this, about that distributing to each of the terms, we must caution. We don't have it in this example, but when we have this, you cannot distribute. It does not equal x squared plus 9. You cannot distribute into a polynomial, whether it's a binomial, trinomial, polynomial, etc. You cannot distribute into there. That's a no. This is x plus 3 times x plus 3. We have 2 of these. So that's why we write it twice. Then you do FOIL, which you'll learn later on. But very important. The only time you can distribute is when it's multiplication or division inside those parentheses. So that's why we're able to distribute that square. So just a little, what do we call it? Forewarning, foreshadowing, that's what we call it. So this is the quantity negative 3 to the 1 times 3, t to the 1 times 3, negative 3 to the third, t to the third, negative 3 to the third is negative 27 t to the third. We have negative 4 to the 1 times 2, c to the 1 times 2, quantity of negative 4 to the second, c to the second. This provides 16c squared. And this is the little technicality that is going to make the difference between getting out of Algebra 1 or staying in Algebra 1, is noticing these little fine details, attention to detail with a negative. And remembering the difference between multiplying like bases and power of a power. So this is the differentiator. That's going to be negative 125x to the third. Negative 4 to the 1 times 3, t to the 1 times 3. You have negative 4 to the third, t to the third. That's going to be, no parentheses, negative 64 t to the third. Any negative number to an odd exponent is always going to stay negative. Any negative exponent to an even, or any negative number to an even exponent is going to go positive, because the even number of negatives will cancel to make positive. Negative 2 to the 1 times 4, t to the 1 times 4, negative 2 to the fourth, and I say negative 2, that really is the quantity of negative 2, t to the 4, that's going to be 16t to the fourth. You have 6 to the 1 times 3, x to the 1 times 3, 6 to the third, x to the third, 6 to the third, 216? Is that 216? No, I don't know if that's 216. 6 cubed, 216, let's go. We have 5 to the 1 times 4, x to the 1 times 4, 5 to the fourth, x to the fourth, 5 to the fourth is 525. 5 to the fourth, 625. Batting 500. X to the fourth, 7 to the 1 times 2, n to the 1 times 2, 7 squared, n squared, 49 n squared. Oh yeah. Oh, all right. So this is 1/2 to the 1 times 2, a to the 1 times 2. We can look at it in this fashion, and we can get 1/4 a squared, or sorry, I'm skipping. That gives you 1/2 to the second, a to the second, 1/2 to the second is 1/4 a to the second. That's one way of doing that problem. Here's another way you could do this problem. We talked about distributing into 1/2 a to the second. We can distribute to each of these, and that's not a bad way. It is 1 to the 1 times 2 over 2 to the 1 times 2 times a to the 1 times 2. So we get 1 to the second over 2 to the second times a to the second. 1 to the second is 1, 2 to the second is 4, a to the second. So both ways is fine. I'm okay with either technique. And here we go here. And now we have our negative. So technically we have negative 1/3 to the 1 times 3, a to the 1 times 3. That gives us negative 1/3 to the third, a to the third. And that's going to be negative 1/27th a to the third. Another way to do this problem, if you wanted, negative 1/3 a to the third. You can take, this is a little crazy, you can take you're going to move that negative to somewhere. Are you going to move it to the numerator or denominator? You can't do both. So you can do negative 1 to the 1 times 3 over 3 to the 1 times 3 times a to the 1 times 3. So I'm just moving that negative to either the numerator or the denominator, but just make sure that it's 1, not both the numerator and the denominator. A to the third, and we still get negative 1 to the third is negative 1, 3 to the third is 27, a to the third, still the same answer. So some little technicality right there. Now we're going to plug in values. So a is 2x to the third, and we're going to plug in 2 for x. We have to do exponents first. So 2 to the third is going to, well, you want to do some, so here we go. We can do it two ways. That's 8 and that's 16. Another way you could have done a, watch this. How many people saw this? 2 times 2 to the third. And do you see that as 2 to the first and 2 to the third? And we can have 2 to the 1 plus 3, which is 2 to the fourth, which equals 16. Anybody see it in that way? Maybe. Let's do b. b is quantity 2x to the third, and x is 2. So, anybody see it? You can do 4 to the third, which is going to give you 64. Anybody see it in this fashion? 2x to the third. Anybody see this as 2 times 2, which is 2 to the 1 plus 1 to the third, or 2 to the second to the third, which is 2 to the 2 times 3, which is 2 to the sixth, which still equals 64. I don't know, just seeing if anybody sees it in that way. It's kind of cool. I'm seeing it in that fashion. And here is c. c is 2 to the third times x to the third. This one's going to be a little bit more traditional. And x is 2. So we have like bases, so we're going to add their exponents. That's 2 to the sixth, which again equals 64. Just some interesting math. You should be open to doing this. Y is 4 to the second. We'll see that as 4 to the 1 plus 2, which is 4 to the third, which is 64. I'm just going to do it one way. I'm going to do it the way that 4 times 4 to the second, which is 4 to the 1 plus 1 to the second, which is 4 to the second to the second, which is 2 times 2, which is 4 to the fourth, which is 16 times 6, is that 216 again? 16 squared, 256. And c is going to be 4 squared times 4 squared, which is 4 to the 2 plus 2, which is 4 to the 4, which is 256. A, x is 2 to the second, y is 4 to the third. These are unlike bases, so we have to simplify. Simplify, simplify. We cannot combine exponents because they don't have like bases. And that's going to give us 256. B is 2 to the second times 4 to the second, which is 4 times 16, which is 64. And C is going to be 2 times 4 to the second, which is 8 to the second, which is 64. All right. These are pretty good. A is x times y to the third, 2 times 64, which is 128. B is going to be 2 times 4 to the third, which is 8 to the third. Grouping symbols before exponents. 8 to the third. Oh, I don't know what 8 to the third is. 8 to the third, 512. And c is going to be 2 to the third times 4 to the third, which is 8 times 64, which again is 512. A is 3 times 2 to the second. We're going to do exponents first, which is 2 to the second, and then 12. B is going to be 3 times 2 to the second. Do grouping symbols. So we have 6 to the second, which is 36. C, we're going to do 3 to the second times 2 to the second. We can't combine those bases because they're different bases. And so 3 to the second is 9, 2 to the second is 4, which is 36 also. A is going to be 5 times 2 to the second. The base of this exponent, is only the x. That's the only thing that's being squared. So we don't square 5, so we have to do exponents. So that's 5 times 4, which is 20. B is going to be quantity of 5 times 2 to the second. We're going to do the grouping symbols. 5 times 2 is 10 to the second, which is 100. And then we'll do C, which is 5 squared times 2 squared. Those are not like bases, so we have to simplify the exponents. That's 25 times 4, which is 100. A is 2 times 4 squared. We're going to do the exponent first, 4 squared, and then we'll do the product, which is 32. We have 2 squared times 4 quantity squared. Now we can do a couple things. We can distribute this, power of a power. So that can be 2 to the 2 times 4 to the 1 times 2, which is 2 to the 8th, 4 to the 2nd. Ooh, 2 to the 8th. I feel like that's 64. I bet you it's more than that. I bet you that's 256. Let's see. 2 to the 8th power, 256. 256, 4 squared is 16. So let's take 256 times 16, which gives us 4096. Whew, that's a big number. Let's do C, which is x is 2 to the third times 4. 2 to the third is 8 times 4 is 32. They went from a super hard one to a super easy one. A is 2 times 2 times 4. We're going to multiply left to right. That was easy. We have 2 times 2 squared times 4. We have to do exponents first. Now we're going to multiply left to right. And C is going to be 2 times 2 times 4 squared. We're going to do exponents first. Then we're going to multiply left to right. And we get 64 again. Oh, we got some division here. Okay. 6 times 2 squared divided by 2. So we're going to do exponents first. 6 times 4 divided by 2. We're going to do multiplication first because it comes first left to right. And we get 12. So orders of operations going to come into play here. 6 times 2 to the second divided by 2. So I'm going to simplify inside the grouping symbols. I'm going to do 6 times 2 is 12. 12 squared divided by 2. Now I have to do the exponent. 12 squared is 144. Divided by 2 is 72. C is 6 times 2 squared divided by 2. We're going to do inside the grouping symbols, we have exponents and division. We're going to do the exponent first, then we're going to do the division, and then we're going to do the multiplication. So again, very important. So here we are going to distribute to each of the things. Notice how they have parentheses around the negative, very important to recognize that. That's going to be 3 to the 1 to the third times 3, n to the 2 times 3. That's 3 to the third times n to the 6th. 3 to the third is going to be 27, n to the 6th. 6 to the 1 times 2, b to the 4 times 2, power of powers, we are going to multiply. 6 squared, b to the 8th, 36, b to the 8th. This is going to be the quantity of 1/3 to the 1 times 3 times x to the 10 times 3. I'm going to deal with that fraction as one term. I'm okay, I can do that math in my head. 1/3 to the 3rd is going to be 1/27th, x to the 30th. You could have written x to the 30th over 27 as an answer also. That's a high school answer. We have the quantity of 1/2 to the 1 times 4, x to the 2nd times 4, 1/2 to the 4th, x to the 8th, and 1/2 to the 4th, 1/2 times 1/2 times 1/2 times 1/2 is 1/16th, x to the 8th. This is going to be 2 to the 1 times 3, a to the 1 times 3, b to the 2 times 3. 2 to the 3rd, a to the 3rd, b to the 6th, 2 to the 3rd is 8, a to the 3rd, b to the 6th. We have our first negative. We're going to have a quantity, x to the 2 times 3, y to the 3 times 3. That's the quantity of -3 to the 3rd, x to the 6th, y to the 9th. -3 to the 3rd is going to give us -27, x to the 6th, y to the 9th. We keep our negative because we have an odd number of negatives. This is 4 to the 1 times 3, x to the 3 times 3, y to the 2 times 3. 4 to the 3rd, x to the 9th, y to the 6th. 4 to the 3rd is 64, x to the 9th, y to the 6th. We have a negative. Let's do quantity of 1 times 4, x to the 1 times 4, y to the 2 times 4. -2, the quantity of -2 to the 4th, x to the 4th, y to the 8th. And -2 in even power is going to be a positive. So we get -2 to the 4th is +16, x to the 4th, y to the 8th. Last one, 5 to the 1 times 2, m to the 2 times 2, n to the 4 times 2. 5 to the 2nd, m to the 4th, n to the 8th, 25, m to the 4th, n to the 8th. And there you have it. Today's your exponential work. Hopefully you comprehended those. Keep practicing and understand the tricky ones. Good luck.